Good morning from cold but sunny Wisconsin, and welcome to day 2 of Streaming Media Connect. Good to see you all here today. Well, I can't actually see you, but you can see us. So thanks again for joining us for our second day of Streaming Media Connect. We are having a week full of panels, presentations, and workshops. This week is panels on everything from technical topics like encoding and ATSC 3.0 to business and strategy focused topics like advertising, live streaming, sports streaming, and a future looking panel that will wrap things up at the end of the week, looking at what OTT might look like in 2025. Then next week, we've got a series of in-depth workshops, both from streaming media contributing editors like Jan Ozer, who's moderating the panel today, and Rob Reinhart and Sean Lamb, as well as from leading technology companies in the industry. And I would like to, before we move on to today's panel, thank our Streaming Media Connect Diamond sponsor, Limelight Networks, who is sponsoring this week of panels. I would also like to thank the sponsor of this session, Cloudinary, and Cloudinary's Amnon will be joining us as one of our speakers. This next session is going to address the ROI of multiple codecs. Now, there have never been more codecs on the market for streaming, and most streaming platforms and publishers end up using more than one in order to maximize reach and minimize costs. So Jan Ozer is going to lead a discussion today with an all-star group of panelists talking about the pros and cons of both established codecs like H.264 and 265, AV1 and VP9, as well as emerging technologies like VVC, LC-EVC, and EVC, taking a look at the costs and benefits of each one. And with that, I will pass things over to Jan, and welcome back, Jan.
Thanks, Eric, and thanks for everybody who's attending, and thank you, Amnon, Colleen, and Anush for joining us today. You know, I'm the codec, or one of the codec guys at Streaming Media Magazine, and I know how to encode them and decode them and all that, but the thing that's really fascinating for me is the whole business side. You know, when do you decide to deploy a new codec, why, and how? And we've established, we put together a cast of characters today who are eminently qualified to help us understand that type of decision making. And I guess I'm just going to, put it to them pretty quickly. We've got joining us today Amnon Cohen-Tidhar from Cloudinary. We've got Colleen Kelly Henry from Facebook and Anush Murthy from Netflix. And I'll let them tell a little bit about what they do in their jobs. But I want to start off, I guess, with Amnon. Which codecs are you deploying today, and where, how, and why? And again, start by telling us a little bit about what you do in your role at Cloudinary.
Hi, so I'm Amnon Cohen-Tidhar. A little bit background. So I've been developing, video products for the last 2 decades. I'm currently responsible for video technologies at Cloudinary CTO office. And before that, I worked as chief video architect at Huawei's Tel Aviv Research Center and led the system architecture at Amimon and LiveView. So I've seen video products from all over, including video conferencing, live video contribution, video delivery, and ultra low latency video for drones, and probably lots of other aspects of video. At Cloudinary, what we are doing, we are basically enabling customers to manage their media, their images and videos. So they can use our services to manage, to upload, to manage, to do optimization, and to deliver their media without, as we all understand, media's complex subject, and we are taking off this mess from our customers. We are automatically adjusting, for example, aspect ratio. So the same video can be displayed on multiple devices without any need to manually generating multiple variants of it. We are using AI for such tasks. And basically our customers are, and any customer that delivers media over the web, such as e-commerce, advertising, entertainment, and e-travel, and many more. Okay, so this is a little bit of a background. Now to your question regarding what kind of video codecs we are using. we're not limiting ourselves. Okay, so basically any codec that we can find value for it and support, and some client that will be able to benefit from it will support it. Obviously, H.264 is the ubiquitously supported codec, so kind of the fallback if we can't deliver something which is better. But we are always trying to figure out what's the best codec for the specific client. So if we're saving for Safari, we will probably use the H.265, which delivers better quality at the same bitrate, or saves some bitrate for a specific quality. The same goes for VP9 over for Chrome and Firefox and those kind of clients that support it. And we are actually right now working on integrating of AV1, which already has quite a good support on desktops, and hopefully in the near future for mobile as well. So that's about codecs. Obviously, we are doing the same thing on images as well. So images, we are all used to the JPEG, which is the common image format, but there are a lot of new and exciting image formats such as AVIF, and currently we're working on JPEG XL as well. So exactly the same strategy goes for images as well.
Okay, thanks very much. Anush, I don't know if we have time for you to tell us every codec Netflix uses, but why don't you go into that a little bit and tell us a bit about what you do as manager of video and image encoding at Netflix.
Sure, you've given my title. So my team is responsible for essentially all the encodes you see on all platforms. We're also responsible for some other mid-level signal processing tasks, but that's besides the point of this panel. So on the encoding side, we are responsible for onboarding and deprecating codecs. Our team also does complexity-based analysis. So any of the tech blogs that you see on this topic come from my team. And of course, I want to plug VMAF as well. My sister team is responsible for our video quality assessment algorithm, which we use for all of our encoding and monitoring downstream. On the codecs itself, it's not terribly wide. So I think Amnon covered most of the codecs. In our case, because we've been around for a while as a company, and because it's a streaming to device, and we've been on several devices earlier, till very recently, we even streamed VC1 and H.263, right? So we have this, I don't want to call it a problem, but essentially we have this legacy user base. Obviously, we cannot disconnect unless external circumstances force us to. And a good example of that was recently, I think, 3DS deprecation. So 3DS used to stream H.263. So we were finally able to deprecate H.263 streaming. So some of our codecs we stream because we have legacy platforms and we need to support them for a while. So we are hoping H.264 is in that bucket of legacy platforms, but it is a pretty wide base today. So H.264, obviously, in many of its variants, so we stream both the baseline and the main profile, as well as the high profile. Amnon pointed out to VP9, we do that as well for browsers, mostly on the Chrome side, and for Android devices. And HEVC, because we have HDR support. So our HDR content, if you're on our 4S plan, then the HDR content is HEVC as of today. And finally, we are pretty gung-ho on AV1. So we have AV1 streaming. I think we had a tech blog last year on AV1 on Android devices. So we already stream AV1 for a lot of our content. Hopefully, it'll increase much more going forward. So there you go.
Okay, thanks very much. Colleen, you up and running?
Hello, I am Colleen Henry. I'm an engineer at Facebook Reality Labs. I kind of work mostly in the VR space, not so much the AR or the other stuff. I wouldn't call myself a codec expert from the perspective of writing codecs. I am an expert in building video systems end to end, and codecs are a fundamental part of that. I just realized partway through the beginning of this discussion that it wasn't actually as complex as I was I thought we were talking about like what I'm doing with my open source project is where it's like on the fly codec switching in real time between like, you know, if you want to do AV1 up to like 360p, cool. You can do that in software decoding in an iOS device, actually, which I think most people don't realize. If you know what you're doing, you can hack that in. So you start up there and then you can switch on the fly to 264 or something like that. So like I said, this is my passion. I have an open source project called Streamline. You can find it at streamline.wtf. It's just forwards to GitHub, and it teaches you how to build a live video streaming system end-to-end, hardware, HDSCI capture, all the ABR level encodes, origin, edge, player, all in one thing, super easily, and it explains it all. You can probably do it in 20 minutes. Most of that's CloudFront provisioning. And or after you build the computer, install Ubuntu, that's on you. I probably have $500,000 worth of video equipment, encoding equipment over there, and I only have one tattoo, and it is an R of the Duck Technologies team, which is, you know, Jim Bankoski and all of them, who eventually became On2 and went to Google and built AOM and all that. So I love them just because they're nice guys who work hard for a long time to give away something for free, and everyone shat on them and didn't, you know, support them, and then they slowly changed the world, and that's awesome. So yeah.
What can you tell us about which codecs Facebook is using today and where?
I mean, I think we've publicly talked about H.264 and VP9 on our blogs. I think we've even talked about testing AV1 on our blogs, right? Members of AOM, right? So beyond that, we're always testing all sorts of other stuff. And I don't know exactly what has been announced or not, or when, or however. And so I'm just not gonna,
okay.
I can talk about things because I know about them, but being in production or using them is completely different.
Okay. All right, from going back to Anush, when does it make sense for you to start considering adding a new codec, and how does a decision like that happen in your organization?
Right, for us, I think there are maybe three considerations, right? The first is the decoder support and the ecosystem. In some cases, it's a no-brainer, as in there is already support. However, in some cases, it may be strategic. For example, AV1, if you are one of the largest video providers and you are part of the Alliance for Open Media, as Facebook is, then you want the codecs that you have worked hard on to actually have decoder support. And for that, you need content. So you generate content so that there is enough decoder support in the market. So some of these are, even if there isn't decoder support, you do it for strategic reasons. The second piece of the puzzle is for us, our CDN, so Open Connect, from where we deploy our video streams, right? In the ideal case, we have one uniform format from which everybody can stream. That is the most optimal way of caching stuff at the edge and also at the IX, right? And that's also the most optimal in terms of cost. However, that is not the world that we live in. So we have to take very careful account of what is going to be the device usage for the content we put, and how is that going to increase our CDN Open Connect cost? Because now you're going to have to keep copies of the same content in multiple codecs if your user base is varied, right? The worst case is you keep all the codecs, you keep all copies of all content in all codecs. And that means, given the limited space on the edge, that means that our customers will have a poor QoE. So we have this unique problem here where we have to model our CDN accurately. And the third is actually the compute cost. So I'm moving back from the decoder, right? The compute cost is extremely important. So while modern codecs provide what 30–50% every generation of the codec, the compute is significantly higher, right? In order to achieve the 30–50% that's claimed. And so again, there is we do analysis to see whether that cost is justified, either for strategic reasons or for the QoE benefits that it provides. So with those three pieces put together, we make a decision on when to onboard a new codec.
Okay. What about the playback efficiency? I guess decoder, because there's so many ways to get decoder support. You know, so I'm getting a lot of pressure from people who are saying VVC now plays on iOS devices. So
why would they pressure you? You have nothing to do with whether it plays there or not.
Well, they good question.
You just talk about people who deploy it, like you're not the one that's like saying yes or no, or
yeah, but I'm the one who says one of the concerns about VVC is playback support and CPU requirements for playback support. So I get a lot of pushback from people who promote VVC saying, hey, it plays, it's fine, it's not that inefficient. So, you know, when you're looking at,
I mean, I haven't played with it personally, and I would 1000% agree with that. I would just say that, like, for example, AV1, people don't realize how you can decode it in software in a single threaded iPhone browser up to certain resolutions with, you know, WebAssembly based decoders. And you can do it on iPad, you can do it. And those are the most locked down ones because they don't even have the media source API, right? So if you can dodge a wrench, you can dodge a ball. So if you can put AV1 everywhere, you can definitely put VVC everywhere too.
So
hardware decoder support is better. It will be, so let's say VP9 right now, right? Obviously,
yeah,
hardware support.
Let me get the sense of that from Anush, and then I'll come back to you. But Anush, how do you negotiate that? You know, do you look for like support, and you don't need browser support because you're going to have an app on every platform. But you know, are you going to have your own, you know, VVC decoder and do it that way, or are you going to wait till it's available on the platform?
I mean, we don't stream VVC, right? So we are AV1 for now. And we do use the decoder that's provided by the browser. So it's not like our app comes bundled with the decoder. Right? We use whatever the system
and
provides.
Use hardware, right, for mobile.
Exactly.
Right?
So it's purely on what the system does, right? If I understand this right, and this is beyond me, right? But if I understand it right, there are hooks through the media interface to either a software decoder, as example would be AV1 and David, right, on Chrome.
Exactly.
Or to a hardware decoder, depending on the platform. So there are several manufacturers who have hardware optimizations in place, and then the browser just offloads to the system. So we use whatever the system provides. And I think Colleen made a very good point on decoder support in software. So in my head, the way the cycles work is it takes a while to develop a codec, right? During codec development, nobody cares about performance, and that's not how you develop a codec. You just write mostly crappy code, right? You're just writing straight C code. Then you have people who know what they're doing, spend a couple of years optimizing the software codec, the software decoder, which is exactly what David did. So we have, for example, 10-bit ARM optimizations today on David. And you can, I believe you can do 1080p 30, maybe even 1080p 60 at real time decoder, right? So I think that's the next generation. And as that optimization goes through, you can get performance on Android, you can get playback on Chrome or browsers, right? Where software decoder is prevalent. And then the next generation is the hardware. So then you get your phones first, and then you get your larger set-top boxes and those which have larger cycle set pins and so on. So in terms of decoder support, Jan, to answer your question, I think we look to see whether there is software decoder and how efficient it is. And honestly, it is a trade-off. You could do cool stuff like Colin was mentioning, which is this codec switching.
On the fly codec switching.
Yeah. So honestly, it is, you take this bet based on strategy. You look at the QoE that the decoder gives you, and then you say that you just not optimized your software decoder well enough for playback. You start there.
Okay, Amnon, why don't you take that question? I mean, when do you start to consider a new codec, and what are the decision points you use whether to implement it or not?
Okay, complementary to Anush. Basically, I think that the first question is, do we see any value in the new codec? Okay, so looking at VVC, for example, I think the first question before we start, really investing in it is, do we see any value when we have, for example, AV1? And obviously, once we see the value, the next questions is all of what Anush says. So we'll have to have client support for client to be able to decode and receive the video, and with reasonable resources. So it's not enough that we are saving bandwidth, but are we draining the device battery for it? So it's another consideration, and obviously the cost is also an issue. So if we're saving very little on bandwidth, but it costs us a lot to encode and store those new renditions of videos, then maybe it's not worthwhile. So I think it's kind of a complex situation where we have to consider all those factors and see first, do we see value for our investment, and second is when is the best time to introduce it, depending on support and the current state of the decoders and the encoders, meaning how much it costs and how much the consumer will be happy to receive it.
Okay. Colleen, why don't you talk about the true cost of adding a new codec in terms of encoding, storage, cache efficiency, and then quality control and development. So if you wanted to deploy a new codec, if you said tomorrow you wanted to start, what would that rollout be like in terms of all the factors I just talked about?
I'm going to take a slightly different direction because I think it'll answer it as best as I can for you. Obviously we have lots of different products. And so sometimes at the scale where if you have your own data centers and your own infrastructure team, it's entirely possible that you're rolling out a codec on a smaller project where there is no ROI necessarily because it's not even monetized, but then all of that engineering work can be reused later in other products. The way I look at it currently is that basically there's a support matrix of decoder capabilities, from mobile devices, Android, iOS, for me, Oculus Quest 2, there's browsers, yada, yada, yada. And from there, you break down things into as granular of levels of understanding it as possible. And that's where I think people are kind of confused here, right? Because I, for example, for live would be encoding AV1 right now, and you would codec switch on the way up on certain devices to 264 where you can't do it. I do it all the way up on the browser. But because of that doesn't make AV1 a non-starter for live, because the compute complexity isn't going past those base smaller layers, but it really does improve the experience in, like, I think the phrase developing nations. And so when you're not forced to, you also don't have to encode all of your videos with AV1, right? Encode your top videos. It depends, how peaky, how long taily your content is, all that kind of stuff. But I look at it for the reason the codec switching is important, and the reason to look at the popularity of content is it's just like any other thing in encoding. It's a cost trade-off benefit overall, but you don't have to treat everything equally, right? And you shouldn't.
What's the QC side? I mean, what's the scary side of launching a new codec? How hard is it within the context of support and all the devices that you just mentioned?
I mean, there's a ton of different, decoders in general are always finicky when they come with the OS, software or hardware. A perfect example was that on the Samsung Galaxy, the one where you strap the phone to your face, the Galaxy VR or whatever, Samsung Gear VR, that's what it was. Samsung said that they supported 4K 30 VP9 hardware decoding, and they did. But why was it that only 24 played back? Well, they counted alt ref frames, which are sort of invisible frames that are not displayed as frames, but there are only 24 frames being displayed. So finding that out, all those little details, is really important. So working with the chip vendors like Qualcomm and all of them to really make sure that for the devices you have a relationship with them on, to make sure that you're maximizing it and that you really know where all the bodies are buried. Sometimes, like if you remove B frames, you can do like 8K or other wacky stuff. Yeah, it's really just the making sure that you don't break the user experience on the other side. And it's easier for my headset-based stuff because I control it, and it's one piece of hardware and we build it. But if you're trying to do the regular Facebook app, you can imagine it's basically every phone in the world, as far as every phone model in the world, there's probably at least one of our interacted with us somehow. That's probably a little bit high, but I was saying every person, I'm saying lots of phone models, right? And we're gonna hit bugs, but at scale, we are very good at finding and tracking bugs and chasing them down and fixing them. So of course, logging is a really, really, really big thing, because you're also doing it blind. You might not be able to find that device, right? Get your hands on one. Logging.
Anush, what's your answer to that? And also, if you could give me I mean, most of the people who are watching this are distributing video to browsers, and the browsers via native support in the browser, and probably don't have apps. So talk about how complicated that is, and then kind of pick up where Colleen left off and talk about supporting different devices, because I know everybody wants a perfect experience with Netflix, and they're paying for it. So I know it's a burden on you.
Yeah. So there are two pieces, right? When you have hardware decoders and you have relationship with your partners, which is the case for say the 10-foot UI, so set-top boxes, TVs, and their ilk. It's not easy, but it is easier because we have a certification process. You work with the vendor, you actually have QC streams. It takes time to get to the market. They give you a pre-sample, pre-market version, and you can actually find bugs and help them fix it, and you get some QC, some guarantee of QC. The world of browsers is really, as my understanding is, it's the Wild West, right? No, it's not true. Okay,
remember,
it's the Wild West.
They get updates though. They get updates.
They get updates. So that's the advantage. They get updates, which is true. The Wild West is because of the fact that we really don't have much control on the processes that the user is running when they have the browser open. So in the case of Netflix, for example, you could have 3 other tabs that's running YouTube. You have a Facebook application open, which is playing some videos on the side. You've got some local process running. So you can have Zoom running, right? So you can have so many things running, which from the browser app really have no view of what else is running, which means that even though in your internal QC check, the video could decode perfectly fine at 720p or 1080p, on the device, your logging shows you that you get drop frames, right? And you really have no idea why. So on one set of user base, you get drop frames, in one other set, you don't, right? So I think the trick in the browser is logging and instrumentation to see why, and to make that trade-off on the how bad is it on your sample on your user base, and how much of this are you ready to tolerate, right? And find that point of efficiency. I don't know if you can always get perfect playback at all resolutions on all browsers for all players, right? So you're going to get some loss, and you tolerate that.
That's the trick, though, is you try to support everything up to as far as it can go.
Fair enough. That is, yeah, fair enough.
Relative to the context.
Amnon, what's your sense of that? I mean, what is your platform support as extensive as what we see with Netflix and Facebook? And what's your view of the QC necessary to deploy a new codec?
So basically, we are deploying mostly for browsers, but also for applications. So some of our customers do develop their own application, and they use our services to stream the media to their applications. And obviously, for us, the relations is that we are doing the QC for browsers, but if a customer of ours is developing the application, they're responsible for QC cycles on their application. Generally speaking, the cost is not only in the QC cycles or the development. There are a lot of costs behind, as we spoke before, the encoding itself, the levels that we allow for encoding, and for example, Colleen said, support the device up to the device capabilities, but maybe that is not always necessary now that we have devices with IDPR, for example. So a device that states that it supports DPR3, which means that actually it has more pixels than logical pixels. Not always this actually gives the value in terms of quality of video that you would expect the additional cost to bring. So there is
you just added cost at the end there. I was just talking about for optimal experience, and that's your tool. And then you figure out where and when you can do that, and you ratchet down the experience until you meet your cost values.
Okay, I totally agree. But what we are doing as well in order to to serve the best quality for a specific content is that we are looking at the content itself, and some content we can boost up the the resolution, because they are simple content and bandwidth wise it will be okay and they will pass the network. On other content, maybe we'll limit the bandwidth, and therefore we might limit the resolution as well, just in order to keep it sane and not to try and consume more network bandwidth than will be served with high quality. So again, there are lots of consideration to take here, and starting from looking at the device itself and what its capabilities, and going back to the content itself and see what kind of content requires what kind of encoding.
Let me get, I guess the two biggest decisions that most people who aren't Netflix or Facebook are facing are, sending VP9 to Chrome and Firefox, and sending HEVC to Safari and maybe iOS devices. So looking at those decisions and how complicated that is, what's your sense of how tough a burden that is from the QC side? I mean, does it work right away, or are you going to have to mess with it to make it work? And then pick either one of those that you want, VP9 to Chrome and Firefox, and HEVC to iOS and Safari.
I think you're switching them, right?
I'm sorry.
VP9 plays on, yeah.
VP9 on Chrome and HEVC.
Okay, did I switch? Okay, yeah, VP9
yeah,
on.
just reverse
okay,
it.
Sorry about that.
Same question.
So talk about that. So, again, that's I think probably the top priority for a lot of people listening or watching. So, talk about how complicated that is from a deployment and QC perspective.
So basically, it's you're required to encode it twice and keep it twice, cache it twice, and everything. On our end, we are simplifying all of this for our customers because they don't have to deal with it at all. They just hand over this task to us, and we're solving it for them. But as you said, it's not trivial, but it's not that complicated.
Okay, so you're saying the QC side of sending VP9 to the browsers or to Chrome and Firefox, and HEVC to iOS and Safari is just it's not that big a hurdle. Because Anush just said it was wild, wild west in the browser side. So you're.
No, what I said is that we are dealing with all the mess for our customers, because there are a lot of stuff that going on with the browser. As Anush said, they are keep changing. For example, the user client that they publish. Okay, so let's say a new version support a new format, but you don't always know that this client is actually a new version because the user agent that it publishes is not up to date, or they publish a lot of legacy stuff within this field. So basically, we are working also with the browser standards in order to make some order into it. We have members that work, within the WebKit community and the Chromium community, and in order to try to make it more usable, that once a browser published, this is what I'm supporting, it will actually support it. And if it does, if it upgrades to a new version and supports more formats or more advanced codecs, it should publish it. Okay, but right now I agree there is some heuristics that we're doing in order to solve it.
Okay, Colleen, let me throw this one at you. When you consider deploying a new codec, is the goal bandwidth savings, quality of experience benefits, or both?
I think that's a stupid question.
I appreciate you being frank with me, but
so the thing is, though, yes, right, all of it, right? You have to consider all of it. But I think this whole show thus far has been like, oh, it depends, right? So if we're talking about how to calculate the ROI, that has entirely to do with your business model and like where you're gonna are you gonna say you're deploying a new codec on all videos, or what if your top video is one video and it makes up 99% of your playback time. Like we would just sit here all day long saying, it depends, it depends, it depends, it depends. And then you would have to call, you know, a product manager or somebody who's got an MBA or, you know, is good at math to figure out the ROI. My job is to try and make it so that the ability to roll out the codec is possible, because it's not all or nothing. If I had to say we have to encode everything all over again and stored in AV1 and VP9 and 264, duh, that would never work. Or else CVC, right? But so if I make it more gradual, where you can take advantage of it for the least cost, for the most gain, then you know, they kind of can give me a knob as far as how much I can like turn it up, maybe, right? But the engineers aren't the ones that necessarily decide how much, because like the video product may go from being strategic for us to not strategic for us, right? We might be investing in and, you know, want to eat more costs or not, right? So I'm not the one making those decisions.
Okay. And there's this one's for you, because Netflix is so big in both per title and multi-codec use. I mean, if you were talking to somebody and they said, you know, hey, we need to cut our bandwidth costs, would you push them to a new codec per title, or how would you prioritize that decision?
Before that, I don't want to qualify my Wild West statement, right? So sorry, Colin, but it depends, is what, right? Essentially, if you're trying to do, for example, 1080p VP9. So to answer your earlier question, VP9, I don't know if it's a problem on Chrome. I think VP9 decoder support.
I can deploy VP9 anywhere. The only place it's hard is iOS, and you can do it. So you're good. You can literally deploy VP9 only everywhere.
That was my understanding as well. What I meant is, now when you start to push up quality, or you start to push up bitrate, and if you're serving video where you're really quality aware. So in our case, because customers pay for our content, we want to make sure we don't drop a single frame, for example, right? In that case, then it goes to Wild West, because we want to ensure that not a single playback drops a single frame, but that is not practical situation. So but depending on what resolution you're doing, depending on whether it's advertisement, whether it's paid content, your thresholds could be different. But then now going back to your question, Jan, on the what would you do first? It depends on where you are. Sorry, Colin. It depends on where you are in the cycle, right? So if you're still doing fixed bitrate encoding on H.264, then there is an obvious big piece that is left for you to pick, right? The complexity-based stuff is just lying there for you to pick. So you should definitely do that, I would think. But if you're already on, say, some sort of cutting edge, as in if you're on VP9, then you start to think intelligently on the trade-off between, say, VP9 and AV1 and the device support, and whether it is worth investing cycles in complexity-based. But it seems like complexity-based is like the lowest hanging fruit, and I don't know why you wouldn't do that for content just off the bat going forward.
Sorry, which one was that one?
Sorry, what is the question?
What was the low hanging fruit?
The complexity-based encoding. So non-fixed bitrate encoding for content.
Okay. How does I know you're not doing a lot of live stuff as far as I know, but let me throw this one at Colleen. How does all this discussion vary between live and VOD, if at all?
Oh, massively. Because if you, again, you know how I was saying, let's say that it's like the top YouTube video ever and you've got 2 billion views, you should compress the crap out of that with, you know, single threaded Gucci VP9 AV1 encoders like Ronald's EVE encoder or something like that, and squeeze as much bit rate as you can out of that. But even if you wanted to spend as much CPU as you wanted and you're doing live, you can't do it unless it actually is live, right? Because if you need to be able to keep up with, say, 1080p, 60 frames a second, there's a point where you just can't scale it anymore across how many CPUs. So that's when you start, things move around, there's trickery. Like, you know, if you want to do like a bunch of like 8K encoding for VR, you could, I don't know, maybe throw like 6 NVIDIA cards in a box, but in the NVIDIA cards for H.264 in the most recent Turing generation, the NVENC stuff, it's actually equivalent to X264. And that hardware you can get fast enough and take the scaling off the chip and stuff. But you sometimes also need to use like an Amazon F1 instance for, you know, getting like the Xilinx NG codec IP on it, because there's just no software-based VP9 encoder that's going to really beat X264 quality per bit if you're trying to speed it up fast enough to do higher resolutions. That's why I just do the, for that I would do the FPGA. So although they can't do 1060, they can only do 10E3 or 72060 right now. But then, yeah, I think LCVC is a very interesting thing. I wish we should come up with a better way of describing it than a codec, right? It's like, it's an enhancement codec, right? And so it's like the whipped cream on top of the cake. And it's a tool that you can use just like a lot of other coding tools. And it's really fast. So you can use codecs that have base layers. The codecs that are really good at smaller resolutions, like, I don't know, WED1, which is great because there wasn't a huge jump from 264 to like VP9 in quality per bit for the lower resolutions. Did a lot of work on EV1. So use that for the base, and then you're like, oh, I can only encode up to here, but then you get the, sort of acceleration factor on top of that for the higher level for if you add on LCVC. Yeah.
Okay. Amnon, this is to you, and I'm going to circle this around to the other ones as well. What's the, we talk about H.264 and HEVC and VP9. Those are kind of the standards, but there's a lot of codecs within those standards, and a lot of people are using FFmpeg, so they get X.264, X.265, and the associated codecs in that. Or I think with X.264, a lot of people assume that is the best you can get, but is the same true for X.265 and the VP9 codec and even the AV1 codec, or do you need to search out better codecs from other suppliers rather than what you get in FFmpeg?
Okay, good question. So I do think X264 is great because it's open and it's out there for such a long time. So it got to the point that, all the improvements are in there, and basically it's one of the best 264 codecs. For the others, I think H265 is obviously have a lot of, competitors, better proprietary competitors than the X265, but it's a question of, again, we're going back to the cost and value. So does the additional cost and the integration and the, even the progress where you have an open source codec, it's progressing and developing and solving issues a lot of time much faster than proprietary codecs. Right now for the AV1 is a good example because AV1 from AOM is quite terrible, I'd say. It's like
so you're
really
saying the codec is terrible?
It depends
are you talking about the
what you test it for. But in
I was
terms
saying encoders, decoders, or the codec performance?
No, not the codec, the actual encoder. Okay.
Yeah, sure.
From AOM.
Yeah.
So obviously right now, as Anusa, I think said before, that they developed a really good codec, but the implementation is quite, not there. It's not optimized. And in this stage, if you want to use such codecs, you might want to look out for better, proprietary codecs. This is the case that we're doing with AV1. We didn't develop ourselves, but we did, we're using a proprietary codec that performs much better. After we've done, quite a lot of testing with AOM, with Ravi, and even Intel's SVT, which is, kind of the best of those three open source codecs, but still you can do a lot better right now. Maybe in the long run, after AV1 will be out there for a while, the open community will make it better, and at some stage.
Which use case are you speaking to right now? Which use case are you speaking to when you're giving, because you're talking about your use cases, and so I'm just curious what those are.
So basically, a use case of, first the latency takes to start a video.
Well, I mean the product itself. Can you describe the product?
Our
experience?
product. Yeah. Basically, we are we're offering services of optimizing media for our customers, and our customers are varied for a lot of different areas. We have a lot of short-term videos that we're supporting So those are videos that you don't do ABR for them. You just do a progressive download and kind of like.
I can give you a really good trick for that. I can give you a really good trick for that.
Okay, I'll be happy.
Let's take that offline. Anish, I want to hear your answer to the question that I just posed to Amnon, and because I was looking at one of your posts yesterday, and I noticed that all of your testing seemed to be done with the codecs in FFmpeg. So I think I saw you were using VP9 from FFmpeg. And I just, if you were talking to somebody now about going to HEVC, would you advise them to use X.265 or to seek another alternative? And same question for AV1 and VP9.
Well, just to be clear, X265 isn't the successor to X264. They license the brand.
I got that. I mean, it's the HEVC implementation.
Just calling that out.
If someone's going to HEVC, I'd advise them to go to AV1. Just fine. But on encoder, yeah, X264 is, I don't know if I've seen anything better than that yet, but there may be others. On the proprietary encoder versus the ones that come off FFmpeg, our comparisons, because we wish to publish results which people can reproduce, we generally compare open source codecs, right? So people can go and reproduce those results. But that's does not necessarily mean that we use those in production. I'm going to say the dreaded word again. It will depend on your cost benefit, right? It depends on what you're doing. If you're ready to pay whatever it takes to license the codec to get the additional 5% gain that the proprietary codec gives you, because it is valuable to you and the amount of content you encode justifies that cost, then there are definitely better options available than the ones in FFmpeg for all the codecs that you mentioned, including AV1, for example. You just have to make that trade-off. In some cases, it's much more than 5%. You can get 10, 15, 20% over what you see in the FFmpeg versions of the encoders. So yeah, I don't know if I answered your question. I may have gone.
No, you did. Why don't you tackle this one for me? The AV1 situation. We started off with the FFmpeg AV1 codec was from the Alliance for Open Media, and then it seemed like the Alliance for Open Media started to endorse the SVT AV1, where they opened up a software project for that. What's going to happen with that? Are we going to see 3 codecs from the Alliance for Open Media? Are we going to see SVT AV1 being the best, or how do you see that sorting out?
Yeah, so I mean, general codec development requires some development code base, right? It is unfortunate in the case of AV1 that libaom happened to be the development code base, and then it was also for some reason the encoder that people used for encoding in production. I don't know of anyone who uses HM or JM to encode H.264 or HEVC, right? So that's generally you generally write it that way, right? You write it where researchers can write whatever code they want. There will be unnecessary macros. There will be completely unoptimized code like nested for loops, but that's not how you write production code. Production code is a separate business of its own, right? So I don't know if I consider libaom as a production encoder now. Although I should say that Google spent a lot of time in the last year or so really pushing libaom performance up on the encoder side. So they've done a good job. Then and because it was written as a research encoder, the SVT effort made sense, right? Because now that is written as a production encoder, it gives you threading and all of the, their model of system is very different from the architecture that libaom is based on. So it made sense for SVT AV1 to exist as a production encoder, which is where they came from. So I don't know if I answered your question directly. I still consider libaom as not necessarily a production encoder. There are other third-party proprietary encoders available. I think Colleen mentioned one of them from Ronald on Eve. Right?
Yeah, Ronald, he has Eve. Yeah.
Exactly. And the SVT AV1 is the other one. Ravi is another one from the Mozilla Foundation. So there you go.
What about
for SVT for live? That's the only one for live.
Yes,
yeah.
exactly.
What about the SVT AV1 question? Is that going to end up being the production AV1 codec from the Alliance for Open Media? How do we see that? As I said, they seem to take it from Netflix and Intel and start a working group within the Alliance for Open Media. Where are they taking that? Is that where most of the development efforts are going to be focused, or something else?
it's a bit beyond me, but I believe there is a software implementation working group whose goal is to see how well these codecs would perform when implemented. Can you optimize them and so on? And so SVT would probably be a base for checking implementation of tool sets, even for AV2, right? For necessarily. But I don't know if I consider that as a research code base, right? libAOM is still the research code base for AV2 development, for example. Yeah, and I don't know if the AOM is tasked with providing a production AV1 encoder, right? It is tasked with creating a standard, so AV1 or AV2, right? And then the production, that is a business, right? So you expect people in the business to step up to write efficient encoders and decoders.
Okay, good. What about the decode side? Colleen, maybe you could take this. I mean, we hear a lot of talk about David and some of the other really optimized decoders. Are they in the browsers? And if they're not in the browsers, how do we get hold of them?
So like you can deploy with native software, you can deploy codecs, and for a long time, so it's like the hardware in the phone for decoding, whatever comes with your browser, and then some trickery that you can do where now with like WebAssembly, you can actually deploy like David and other things in a browser. You send down the decoder with the page, and I think that's going to change everything, absolutely everything. If you control both ends and you can actually deploy all of that on the fly on all platforms, and just maybe have some old 264 ones around if somebody's got delivered to an old DVD player or something. Like it is totally possible. I can, let's see, there's a project, the BRION, Brion, I'll get the link so you can send it. He did a live, oh yeah, here we go. It's a weird name because it was originally ogv.js, but the project is not just ogv now, but this is, and right now that link I just sent you actually has the assets for the videos are down right now, but the GitHub here, that is a complete demonstration end to end of, being able to do, actually, sorry, this isn't end to end one, this is just the decoder one. So that there, which we can put, it's github.com/brion/ogv.js. And it shows that it totally works. Downside is right now, there are some threading concerns. You don't necessarily get multi-threading in every browser. So you might get just to 360p on iOS web if you wanted to, but that might not, if it's a vertical held phone, that's not too bad. So there you go.
Okay. Amnon, let me throw this one at you because you're kind of in the situation of, general purpose encoding for browser-based stuff. When would you start to consider looking at a codec like VVC or EVC? When does that hit your radar screen to start seriously even considering it?
So I think there are a couple of phases here. First is actually about right now when the codec is ready for some initial testing, and then what we're doing is trying to see the value in it. Okay, so if for example it doesn't give any additional value compared to AV1, then we might consider it more later. But if it does improve either performance in terms of CPU or bandwidth to quality ratio, then it's becoming interesting. And then we are looking into the industry to see when or how to push in the decoder side into the browsers, into the applications. So it all must come together in order for us to actually push it into production. But we are working, testing it and validating it quite a long time before we decide if we want to invest it into production.
So where, given that VVC has no browser support at this point, where is it on your radar screen? Are you doing testing now, or are you just saying, you wake me up when it's in Chrome?
No, we are not waiting, obviously, because you have to have some time of development in order to actually integrate it into the system. But right now, what we're doing is trying to evaluate it, try to figure out what are the pros and cons of using VVC when we have those other codecs that are already in production. And once we understand that, okay, for those use cases, it's interesting to use VVC, we'll progress with trying to find the best library that supports it for the encoding, trying to understand the pricing model for it, trying to understand the exact use case where we want to actually deploy it, and obviously need the whole ecosystem to support it as well, because we can't send something that the client can't play.
Okay, I think we have time for one more question. I'm gonna ask this one of Anush, and you may not know the answer to this, but one of the things that really has projected HEVC into the living room has been HDR support. So how do we see or technologies like Dolby Vision start to work with AV1 or maybe even VP9, or are there workarounds where you don't need that, but on the installed base of TVs that are out there today? I mean, how do you see the whole HDR thing shaken out over the next 1 to 2 years?
It's probably worth pointing out that Dolby Vision is not the only HDR support, right? There's HDR10, there's HDR10 plus, and there's also HLG, but I think that's probably dead.
Are they supported by AV1 today, or?
My understanding is that AV1, it's probably the other way around, but I do think that Dolby Vision supports AV1. I believe that HDR10 plus does as well, and HDR10 does too. So I don't see any, like a short answer is I don't think there are problems with HDR support in AV1, as in there isn't any tooling or messaging that is missing. It's probably testing that's required.
Okay. Well, that was a quick answer. Let me think if there's anything else I want to ask. Colleen, what can you tell us about live VP9 encoding or transcoding?
So the best way to do it, and by the way, sorry for being so blunt earlier. I just, what I was trying to say was more like you're trying to boil the ocean in one question, and I just sounded like a jackass, so I apologize. But if you want to do high quality live VP9 encoding and actually really get your quality per bit, high enough that it's actually worth doing that over X264, you're going to want to use an FPGA with the Xilinx, with the, because Xilinx bought NG codec, but the NG codec IP. You used to be able to do it on AWS with F1 instances, where you could just get this per hour sort of VM thing. Now, you probably have to call them up, buy some cards or whatever, but that's the best one for live, like super low latency and that kind of stuff. And other than that, SVT VP9 exists, but it's not really working. And I wouldn't do live with that.
What about AV1? Did you say SVT AV1 was the only way to do live?
SVT AV1 is how I would do. Yeah. So what I'm going to do is streamline for the next one. We're going from being a simple educational tool to a super complicated one, just to show here's the baseline, here's the Gucci high end. So SVT AV1 is super multi-threaded. So the hardware we spec'd out. Oh shit, actually, I didn't mean to bring props, but I actually have it right here. And so we've got 64 cores of AMD CPU and 120 threads. And if you go to the Pharonics test suite, you can see just how much thread. I love running HTOP and just all 64 cores pegged. And then I offload all of the scaling to the GPUs, actually the GPUs, I'm not mistaking that for NVENC. And then we do 264 encoding on the NVENC, and then we might add an FPGA for other stuff there. And so basically the mixture is, I think that's the mixture. I would do VP9 plus 264 if I had an FPGA and I didn't want to do AV1, but I would probably skip to AV1 first because it's really good at the lower resolutions, right? But the best is actually you do VP9, AV1, and 264 all at once. For live, you probably will get to 360p, maybe 540p with AV1 as your max resolution, but it doesn't matter because that's for mobile devices. So, but the thing, let's say you're watching your laptop, you plug in your TV, switch to 264, and you can do it on the fly.
Okay, I'm going to kick it back to Eric to close it, or should I just?
No, that was great. Thanks so much to all our panelists. And I know there are a couple of questions in the Q&A. I will try to respond to those offline with some links that might give some insight into the answers to those questions. So thanks again to Jan, Amnon, Anush, and Colleen for a great discussion. Thanks again to Limelight Networks for sponsoring Streaming Media Connect. And thanks to Cloudinary for sponsoring this session. We will be back in about 27 minutes with the first of our tech talks with leading industry vendors. So hope to see you in a few minutes.